Good morning, everybody. Myself, Basavarajeshwari Patil, Assistant Professor, Department of Electronics and Telecommunication Engineering, Walchand Institute of Technology, Solapur. Today, we are going to discuss on the topic Programmable Logic Devices. So before we begin, we'll learn about the learning outcomes. At the end of the session, students will be able to understand about the PLD and its purpose, difference between SPLD, CPLD and FPGA, different types of SPLDs and some problems and their implementations, identify key applications of PLDs, recognize advantages and limitations of PLDs. Contents of this are introduction. These are, you can say, some of the contents like introduction to PLDs, comparisons of PLDs, applications, etc. So before we begin, we recall about the logic gates, combinational logic circuits, sequential logic circuits. So what are logic gates? Logic gates are the basic building blocks of the digital circuit, like mainly AND, OR, NOT and NAND are the basic logic gates. So combining these, we will form the combinational logic circuits. Along with the combinational circuits, if you are using the memory, then it will form the sequential logic circuits, and it is formed by, again we have the fixed ICs which has predefined functionalities and they are not programmable and they are fixed, whereas PLDs are like they are programmable. So next we'll move on for the introduction to the PLDs. So PLDs, programmable logic devices, is an electronic component used to implement digital logic circuits. Unlike fixed function logic ICs, PLDs can be programmed by the user to perform variety of logic functions. The key features are they are programmable, like logic functions can be defined after the manufacturing. They are more flexible, that is they can be replaced multiple fixed function ICs. Reconfigurable, like some of the types can be reprogrammed multiple times like FPGAs. They are compact, that is they have the reduced number of components and wiring in digital systems. So these are the some of the types or the classifications of PLDs. Mainly first two are the SPLDs and HPLD. HPLD stands for simple programmable logic devices, which each has the classifications like ROM, PLA, PAL and GAL. And HPLD can be differentiated into two types, that is CPLD and FPGA. So mainly as we discussed the types of PLDs, SPLD stands for simple programmable logic devices and it consists of ROM, PROM, PAL and GAL. So next CPLD, as we discussed, it is more complex compared to the SPLD, and fixed programmable logic gate arrays are programmable and complex compared to the CPLDs. So first we will discuss about the simple programmable logic devices. It is the earliest form of programmable logic device used to implement small logic circuits. SPLDs contains a limited number of logic gates, flip-flops and interconnections that can be programmed by the user. In SPLDs, programmable array is typically based on AND or arrays. SPLDs are low complexity, low cost and low power devices with a fixed architecture and limited logic resources compared to the CPLDs and FPGA, while still retaining their programmed configuration even after the power is switched off. Examples, as we discussed earlier, PAL, PL and PROM are the best examples for the SPLDs. So this is how they are classified by the programmability, that is PROM, PAL and PL are classified mainly depending upon the programmable capacity of AND and OR arrays. So PROM consists of fixed AND arrays and programmable OR arrays, whereas PAL consists of programmable AND arrays and fixed OR arrays, whereas in PAL we can both program AND arrays and OR arrays to get the output for a given required inputs. So PROM, programmable read only memory, The AND gate array within the PROM is fixed and acts as a decoder, generating the required input combinations. So OR gate array is programmable here. Users can program the connections to these OR gates by applying the electrical pulses, effectively setting the binary data to be stored. It is one-time programming. The key characteristic of PROM is it is ability to program only once. Once programmed, the data is permanently stored and cannot be altered or erased. PROMs can only be programmed once, making the stored data permanent and unalterable. Because of its reliability, PROM is widely used to store firmware in microcontrollers and other devices. So we'll see some implementations of SPLDs. First, we'll deal with the PAL. So the given problem is implement the following Boolean expression with the help of PAL. So they have given the two expressions, x is equal to a into b plus ac bar and y has ab bar plus bc bar. So for these given two functions x and y, we are implementing. So as we are using PAL, here the four expressions, four terms are used, ab, ac bar, ab bar and bc bar, and we are using the four AND gates. So AB AC bar and AB bar and BC bar are connected for different four AND gates, and their output, whatever we are getting, we are connecting with the two functions x and y, where where we have the fixed OR gate. Next, we'll implement PLA with the two expressions x and y. Here the x is given with the expression AB plus AC bar and y is given with the AB bar plus BC plus AC bar. See here, so for 5 terms we are using only the 4 terms. That is the difference between PAL and PLA. So we have taken the common terms here. So AC bar is common in x and y functions. So instead of taking AC bar for 2 times, only it is taken for the single time, so that we are, instead of taking 5 AND gates, we are using only 4 AND gates, which is reducing the utilization of number of gates to construct the PAL. So same concept as in the PAL, we are connecting A, B to the first gate, AC bar to the second gate, AB bar to the third gate and BC to the fifth gate, and the expression AC bar y is not executed, or it is connected, as it is common in both x and y functions. And here, as both are programmable, here for the x is connected to the AB and AC bar and y is connected to AB bar, BC and AC bar, and we are getting the functions x and y. So next we'll move on for the difference between PAL and PAL. So here, programmable array logic. So the PLA stands for programmable logic arrays. The construction of PAL can be done using the programmable collections of AND and OR gates, as we discussed. The constructions of PLA can be done using the programmable collections of and fixed collections of OR gates. The availability of PAL is more in case of PAL. Availability of PLA is less in case of PLA. Flexibility of PAL is more. Flexibility of PLA is less. The cost of PAL is low. The cost of PLA is very high. The number of functions implemented in PAL is large. It is functions implemented in PLA is less. As we have seen already, that is, if the terms are repeated, we are not utilizing those terms again and again. Instead of that, we are taking only one term of that. So that reduces the number of functions. The speed of PAL is high. The speed of PLA is low compared to the PAL. So comparison of PLDs as we can do is, that is SPLD, CPLD and FPGA. SPLD's density is low CPLD's density is moderate, FPGA density is very high compared to the CPLD and SPLD. The logic implementation in SPLD is simple, whereas it is deterministic in CPLDs, and it is highly flexible in the FPGA. Applications of PLD. There are many applications of PLDs, among them digital system prototyping, communication systems, signal processing, consumer electronics, and control logic and embedded systems, and along with that educational purposes we are using the PLDs. Advantages and disadvantages of PLDs are they are flexible and reprogrammable. That is a more advantages that they are reprogrammable and have the faster prototyping, reduce IC count in the designs. The disadvantage of these is costlier for larger volumes, limited performance compared to the ASICs. As ASICs are fixed programmable, they cannot be changed, their performance is greater, accurate, they are more reliable compared to the PLDs. So lastly, we come to the conclusion that PLDs provide flexibility and ease of design. SPLDs are more less complex compared to the CPLDs. CPLDs are less complex to the FPGAs, where we can do the field programming in case of FPGAs. It shows the growth of the PLDs widely used in prototyping and digital systems essential in modern VLSI differences. These are the some of the references we are referred with the Xilinx, Intel, and many of the books like Digital Design, Verilog examples by Pong Chu, and PLD Basics. Special thanks to the Walchand Institute of Technology, Solapur, IDP in Education Technology, and IIT Bombay for providing me to do this session. Thank you.